In general three-dimensional space, a linear line, expressed by this equation here, will intersect a two-dimensional plane at one point, generally. There are a couple of exceptions, which I will cover in my next few examples. Excuse me. So what we've essentially got here is a set of simultaneous equations. So we've got four equations in four unknowns. Don't forget that the vector r is actually just the vector x, y, z. So we've got x in terms of lambda, we've got y in terms of lambda, and we've got z in terms of lambda, and then we have an equation up here, x, y, and z. So just like with any intersection points, I'm going to solve these set of equations simultaneously. Four equations and four unknowns. So I'm going to use my definition for x as being minus 2 plus 9 lambda, y as being 6 minus lambda, and z as being minus 5 minus 3 lambda, which I get from this equation here. And I'm going to plug these two definitions into the equation of the plane. And what that's going to give me is a linear equation in lambda. Okay, a linear equation in lambda. So x, so it's going to be minus 2 plus 9 lambda, minus 3y, so it's going to be minus 18 plus 3 lambda, plus 2z, so it's going to be minus 10 minus 6 lambda, and that must all equal 8. Okay, so a nice linear equation in lambda to solve. 9 lambda plus 3 lambda is 12 lambda, minus 6 lambda is 6 lambda. That's going to equal 8 plus 2 plus 18 plus 10, 20, 30, sorry, 10, 20, 38. Therefore, lambda equals 38 on 6, which is 19 thirds. Okay, so that's my value of lambda. Once I get lambda, to find the actual point of intersection, I can take my value of lambda and plug it back into my definitions of x, y, and z. So in this case, x is going to be minus 2 plus 3 times 19, which is 55. Y is going to be 6 minus 19 thirds. Well, 18 thirds is 6. So I've minus an extra third, so that's just minus a third. And then in the z direction, I'd get minus 5 minus 19 gives minus 24. So that's my intersection point of this line and this plane. So the exception cases then. Two exception cases. There's one where you have a plane as such in three-dimensional space, and then your linear line is somewhere above it such that it's perpendicular to the plane everywhere. In other words, the line is parallel to the plane, so it never actually intersects. And that's the case we're going to have here. So I'm going to take my definitions of x and y, and again I'm going to plug it into this equation. So x is 1 plus 2 lambda, so it's going to be 3 plus 6 lambda, so I want 3x. Plus 2y, so it's going to be minus 4 minus 2 lambda, and then minus 4z, so it's going to be plus 4 minus 4 lambda, and that's going to equal 10. So again, it's a linear equation in lambda, except that this time 6 lambda minus 2 lambda minus 4 lambda, they all cancel out. And I'm left with the equation 3 equals 10, which is clearly a contradiction. Okay, 3 doesn't equal 10. In other words, there's no value of lambda which satisfies this equation. Therefore, this line doesn't intersect this plane. And the only configuration you can have of that in 3D space is that the line is parallel to the plane. Okay, quick little check. Before you actually do any working, you could do the normal of the plane, so 3, 2, minus 4, dot it with the direction of the line. If that comes out to be 0, then you know your lambdas are going to cancel. And you're going to end up with either this case, or you could end up with this case. What happens if it equals 3 rather than 10? So this is exactly the same line, almost the same plane, except now it equals 3 rather than 10. So when we go through the algebra, 3 plus 6 lambda, minus 4 minus 2 lambda, plus 4 minus 4 lambda equals 3, we end up with the equation 3 equals 3. Well, that's true, whatever value lambda takes. Okay, lambda's cancelled again, but this time we end up with an equation that makes sense. 3 does equal 3, and the configuration we've got here is that we've got the plane, and the line is actually on the plane. So every point on the line satisfies these equations. So we can conclude the line is on the plane, and the solution is just the equation of the line. That is the solution. This is where the line intersects the plane, at every point on the line, because the line is on the plane.